Welcome to The Explainer. I'm your lead detective for today's forensic investigation, and we are stepping right into a very specific, highly active crime scene. Picture this, if you will. It's the exam room for the Cambridge AS and A-level mathematics paper, Syllabus 9709. The paper is finished, the clock is run out, and the room is empty. But as we survey the scene, something is terribly, terribly wrong. High tariff marks, we're talking the big, valuable points that literally make or break a grade, have been completely stripped from the exam papers. Students who thought they had a rock-solid alibi are suddenly finding their grades bleeding out. So what's our case file today? It's topic 6.4, sampling and estimation. Specifically, we're looking at the brutal battleground of sample versus population. We are going to lock down this crime scene, analyze the evidence, and figure out exactly how to stop these precious marks from going missing.
Think about this number for a second. 15%. Really let that sink in. According to our examiner intelligence, topic 6.4, sampling and estimation, accounts for approximately 15% of the total marks in the Mathematics 9709 examination. When you walk into that room, 15% of your entire grade is just sitting there, up for grabs, in this one specific area. And yet, crazily enough, this is precisely where we see the absolute highest volume of missing marks. Candidates are letting a massive chunk of their final grade just slip right through their fingers. And the worst part? They often don't even realize they've made a fatal error until it's way too late.
Okay, let's dive into this, because this really is the million-dollar question, right? Why exactly are these marks vanishing? Well, to help us analyze the evidence line by line, I want to introduce you to my two rookie forensics agents. First up, we have Agent Alex. Now, Alex is completely obsessed with loose footprints and raw facts. Alex will calculate the sample mean perfectly, but then completely fail to mathematically explain why that mean represents the population. Then on the flip side, we have Agent Sam. Sam is all about the vibe. Sam will just assume that any random sample is a flawless, perfect mirror of the population, but gets super careless with the actual mathematical proof. Look, most students taking this exam fall into the trap of being either an Alex or a Sam, but neither approach is going to survive the examiner's intense scrutiny.
All right, moving into Section 1, the Forensic Architecture and Core Principles of 6.4. To solve this case, we have to look at the theoretical DNA of a perfect, full-mark answer. You absolutely cannot just stumble your way into estimating a population from a sample. It doesn't work that way. You have to build your case on three distinct pillars. First up, precise definitions. You need to know the exact mathematical difference between a sample statistic, which is the raw number you measured at the scene, and a population parameter, which is the true underlying reality you're actually trying to guess. Second, causal relationships. How does changing your sample size mathematically affect your variance? You have to prove that cause and effect. And third, syllabus integration. Sampling doesn't just exist in a vacuum, right? It connects directly to normal distributions, probability, and hypothesis testing. And this brilliantly illustrates the harsh reality of the exam room. The quote we're looking at is a legitimate smoking gun pulled directly from the autopsy reports, the principal examiner reports themselves. Candidates referencing cross-topic connections achieve significantly higher marks. Isolating concepts is a fatal error in your exam strategy. Seriously, if you try to solve a sampling problem without integrating your knowledge of the normal distribution or standard error, your entire argument is going to fall apart. The examiners are explicitly telling us that the absolute most successful candidates are the ones who can link different parts of the crime scene together.
Next up is Section 2, the procedural framework and step-by-step analysis.
So we know the theory, but how do we actually execute when the pressure is on? When that clock is ticking down, you can't just panic and start throwing random numbers at your calculator. You need a precise forensic protocol to ensure you extract maximum marks and avoid those fatal structural drops. Here is your 5-step method to mathematically reconstruct the text. 1. Deconstruct the question. Ask yourself, what is the exact command word? Are they asking you to calculate or to estimate? 2. Extract relevant data from the texts and tables. Pull out your sample mean, grab your sample size. 3. Select your analytical framework. Are we using an unbiased estimate of population variance here? Figure that out. 4. Execute with clear notation. This is absolutely vital. And finally, 5. Present with correct terminology. If you call a parameter a statistic, the examiner will dock your marks immediately. Follow these 5 steps strictly, and you'll build an airtight case every single time.
Okay, I'm pausing the case file for a quick mid-investigation bulletin. If you are truly serious about securing your grade and outsmarting the examiners, you need the right tools in your kit. To ensure you never miss our weekly forensic investigation breakthroughs, you need to subscribe to Ace the Exams at the handle @AceTheExams right now, and make sure you turn on all notifications. Keep your skills sharp. All right, let's get back to the evidence board. Welcome to Section 3, the live forensic workshop, where we analyze the evidence. Now, what's really interesting about this comparison is seeing where things go terribly wrong versus where they go perfectly right. We're going to put our rookies to the test here. I want you to look at the evidence as if you were the examiner holding that red grading pen. We are cross-examining two very different approaches to a high-tariff evaluation question. First, we have Sam's flawed student approach. Sam essentially assumes that a larger sample is always, automatically, perfectly representative. It relies on vague, sweeping statements without citing any of the mathematical limits. It is a classic rookie mistake, versus the top-scoring evaluative thinking, what I like to call the master detective's approach. This candidate actively questions assumptions, considers different perspectives, and, importantly, justifies their decisions with hard, undeniable statistical evidence. They don't just write down that the sample is good, they calculate the unbiased estimate and logically explain its reliability based on the exact context. To ensure you're always operating on the winning side of that comparison, you have to use this rigorous timeline. First, identify the given information. Then, break the problem down into logical steps. Solve it systematically. After that, always check for reasonableness. Think about it. If your estimated population mean is wildly, impossibly different from your sample, you've definitely calculated something wrong somewhere. And finally, make justified recommendations. This deconstruct, solve, evaluate loop is exactly how you crack literally any complex comparative analysis problem in Topic 6.4. Let's move down to Section 4, the autopsy results and principal examiner warnings. It is time to head down to the morgue and take a hard look at the actual autopsy results pulled directly from Cambridge Examiner records. And listen, these are not hypothetical scenarios. These are the actual fatal wounds killing student grades year after year. Here are the top 3 causes of death for exam marks. Number 1, forgetting proper format. Number 2, forgetting to check that format and presentation before rushing on to the next question. And number 3, which is by far the most lethal, answers are not specific to the context given. Let me translate that into plain English for you. If the question is about sampling the weights of apples in an orchard and your final answer is just a naked floating number without any units or a reference back to those apples, you will lose the evaluation mark. It's that simple. A failure to anchor your mathematics in the given context causes a massive, entirely avoidable drop in your points. Finally, Section 5, the final lifeline, method marks. So we've talked a lot about building a perfect case, but let's be real. What happens when you accidentally drop a negative sign because you're sweating under the pressure? I am here to offer you the ultimate insurance policy, the method mark strategy. In the Cambridge 7909 mathematics exam, method marks are awarded for demonstrating the correct analytical process, completely regardless of whether your final calculated number is actually right. Think of these as your forensic trails. You are essentially leaving footprints in the dirt for the examiner to follow. Even if your final destination is wrong because your calculator slipped, the examiner can trace your footprints and say, okay, they applied the correct formula for the unbiased estimate of population variance, and they will still award you precious marks for that process. So, the crucial point is this major examiner alert. Show your working. It is the ultimate crime to leave your working out of the exam paper. Do not just write down the final answer. If you try to do everything in your head, or if you scribble it on a piece of scrap paper that you end up throwing away, and your final answer is wrong, you get 0. Nothing. A complete blank. But if you show your working, step by step, you activate the method marks lifeline. It is hands down the most powerful tool you have to salvage a grade when things start going sideways. And that brings us to the end of today's case file. You now know the theoretical DNA, the procedural framework, the examiner's top warnings, and the absolute life-saving power of method marks for 6.4 sampling and estimation. Please do not let your marks become just another statistic in the examiner's autopsy report. If you found this explainer valuable, I command you to subscribe to Ace the Exams right now, enable all notifications so you don't miss our next breakdown, and drop a comment telling me your current level and your target grade. But before you go, ask yourself this as you prepare for tomorrow's revision. When that clock runs out, will your exam paper look like a perfectly solved case or just another tragic, unsolved mystery? Class dismissed, detectives. Stay sharp out there.